In this lesson, we will talk about how to understand the correlation coefficient. So technology uses linear regression to find a line of best fit. It often shows a value r, which is called the correlation coefficient. Values of r range from -1 to 1. Values close to -1 indicate a strong negative correlation. Value close to +1 indicate a strong positive correlation. And values close to 0 indicate no correlation at all. So let's talk about this in example number 1. The table shows data for 8 hockey teams in a league. Use the link provided to find an equation of the line of best fit. Click the box labeled Use Data Grid to input X and Z values to easily enter data. Identify and interpret the correlation coefficient. So this link is also on Schoology and also on the screen on the right side. So here's the data that I'm given. So the first thing that I'm going to do is I'm going to click this data grid box. That'll easily allow me to type in all of the data. So 219. I gotta type it in. 21. Let me try that again. Let me see if this will work. There it is. So I type in 219 for the first box. The second box I type in 249. Next box I type in 215. Whoops. 183. 282, 241, 263, and 256. And don't forget your Y values as well. So this is 39. This is 50, 36, 28, 55, 41, 50, 48. So once you have all that plugged in, what you are going to do is finding the correlation coefficient. So click compute, and voila, there it is. Your R is right here. R equals 0.9772. So let's go back to notability. So I found that my correlation coefficient is R equals 0.9772. What does that mean? That means, according to the notes that are above, there is a strong positive correlation. Now, always ask yourself, does that make sense? Well, think about it. The more goals you score as a hockey team, the more games you're going to win. So that makes sense. Okay? So now why don't you try this practice number 1. To find the equation line of best fit, all you have to do here is click on, instead of correlation coefficient box on the left, click on equation of regression line. Okay, and we'll go over that in a little bit. Okay, the table shows the number of days spent training and the race times for several people in a race. Use the link provided to find equation line of best fit. Click the box label Use Data Grid to easily enter data. Okay, so now let's do it again. All right, so if I'm going to enter the data, let's see how this works. Let me erase all of this. So it's going to be 2. This will be 14. I'll change that. Give me a second. That will be 7. This will be 5. 21. And 18. And let me get rid of these boxes as well. This bottom one will be 25.45, 22.3, 23.85, 24.1, 20.9. The last one is 21.2. Let me get rid of these. Okay, so if it asks for the equation of the line of best fit, you could click on the regression line, click compute, And voila, here it is, right there. So in this one, it gives you with the y-intercept in front. So what I want you to do is when you write it out, I want you to write the slope test in front, so it is always in the term y equals mx plus b. So if I were to write it out, it would be y equals negative 0.2328x plus 25.57. And then it also says interpret the correlation coefficient, or find and interpret, so make sure you do that as well. Looks like r is equal to negative 0.9906, which means it has a strong negative correlation. And once again, does that make sense in the context of the problem? And I would agree. And the reason it would have a negative relationship is because think about the number of days you train. What is going to happen with your race time? Your race time would actually decrease. So the more you train, the faster you'll get, aka your race time will decrease. So that makes sense. Now it's asking, interpret the slope and y-intercept. Your slope is this number right here in front of your x, so 0.2328, negative 0.2328. So what does that mean? That just means your race time is shrinking at a rate of negative 0.2328 minutes per day of training. That's what it is. That's what your slope represents. Now to identify your y-intercept is 25.57. That's always your start, your initial. So you can say that at day 0, race time was 25.57 minutes. That's all it is. Your start of that. All right, and then moving on to the next example. Example number 2, the table shows the number of bats in a cave each year from 2016 through 2023, where x equals 0 represents the year 2016. Assuming this trend continues, in what year will there be 65,000 bats in a cave? All right, so if it's asking for a relationship or prediction, you are always going to find the equation of best fit, aka you are finding the regression line. So let's do that real quick. So for this one, this is easy. It's just going to be 0, 1, 2, 3, 4, 5, 6, 7. This will be 327, 306, 299, 270, 254, 232, 215, and 197. All right, so I'm going to find the equation, and when I click that, I get that the regression line is there. So let me write it out. So I get that y equals negative 18.83x plus 328.4. All right, so what am I going to do? How am I going to use this information to predict when there's 65,000 bats in the cave? Well, take a look at my units. My y units represents bats. Right, so to figure out when it's going to be a 65,000, I'm going to plug in 65 in for y, right? Because bats represent 65. I'm also not going to just plug in 65,000, right? 65,000. I'm just going to plug in 65. Why? Because bats are already in 1,000. So instead of y, I'm going to plug in 65. So now you won't always plug in that number in for y. Sometimes you'll have to plug it in for x depending on the unit. So you have to take a look at your table and see what units are presented where's. But it just happens in this case, it is your y. All right, so now let me rewrite it and let me solve for x. I'm going to subtract 328.4 minus 328.4. I got negative 263.4 is equal to negative 18.83x. My final step is to divide by 18.83. I get x to be equal to 13.99, which is roughly 14. So what does that mean in the context of the problem? Remember, x represents years after 2016. So if it's 14 years after 2016, year 14 is going to be 2030, right? Because 14 plus 2016 is going to be 2030. Okay? Knowing this, why don't you try this next one on your own, and we'll go over in a little bit. All right, so don't forget, you always have to enter the data into this website, unless you want to do it by hand, which you, by all means, feel free to, but I'd rather not do it by hand. You get 4.2 as an Xbox, the next one is 4.4, 4.5, 4.6, 4.7. Get rid of these numbers. So I have 27 here, I have 22, I have 18, I have 16, 11, and I have 8. Let me read the problem as well. The table shows the heights of a high jump bar and the number of people who successfully complete each jump. Predict the number of people who will successfully complete a jump when the bar is 5 feet high. All right, so let's start with the equation that I'm given. The equation I'm given is y equals negative 25.88x plus 131. Okay, so then you're trying to figure out the number of people that will pass when it's 5 feet high. Take a look at your units. Height is in feet. This is your x. So I'm going to substitute x for 5, and this one I'm solving for y. Notice how it's different than the other example we did above. So negative 25.88 times 5 plus 131. And when you do that, hold on one second. Let me plug it into my calculator. I got negative 129.4. Oh, I did something wrong. It shouldn't be 12. It should be 11 here. I apologize for that. Let me fix that real quick. And I was going to say, something didn't seem right here. Let me try that again. So the actual equation, that makes more sense. It's y equals negative 26.47x plus 133.5. Negative 26.47 times 5 plus 133.5. And that should be negative 132.35 plus 133.5, which is 1.15. So if you were to predict the number of people who will successfully jump, it's roughly one person, right? Because 1.15 is around on average one person. So that is it for today's lesson. Circle your level of understanding 1, 2, 3, 4, 5, and we'll call it a day.